Welcome everyone, my name is Marton Sabli, responsible for the orchestration solution Ericsson. This year, we're going to talk about a number of new capabilities as part of the Ericsson Dynamic Orchestration launch. If you look at 2019, it's very much the year of 5G. Many of our customers have started this journey, and many more will start this year. Looking at what we have learned so far, most of our customers are looking at radically reducing TCO, primarily by automation. They're also looking at how to consolidate the different OSS systems in different domains. In the past, it was quite common to see one OSS system for radio, one for core, one for transport, and so on. But many of our customers are now introducing a horizontal, multi-domain, end-to-end, model-driven system, which is very much what dynamic orchestration is. And then finally, once a high level of automation is achieved, customers are ready to harness the new capabilities introduced by 5G, addressing industry verticals, exploring new business models, and also exploring new delivery models. If you look at what has happened in the past, many of our customers have already introduced virtualization to some degree and also understood that virtualization alone is actually reducing the TCO due to complexity that there is also a physical and a virtual environment at the same time. And this situation is going to actually become even more complicated because the data center transformation is also stretching the data center capabilities, not just from central sites, but also edge sites. Edge sites being potentially a public cloud or an edge of the mobile network or an edge in the enterprise environment. The technology becomes more complex as well, because next to virtualization and already existing physical nodes, we are also introducing a container environment, container as a service, with a cloud-native VNFs on top. This year, Ericsson is launching a complete solution addressing 5G, a 5G access, 5G transport, a packet core solution, Ericsson Cloud Core, addressing a dual mode 4G, 5G mobile broadband capabilities, and also Ericsson Cloud Communication, which is our Volta solution adapted to work in a 5G environment. In this presentation, we're going to talk about the dynamic orchestration, which is the pre-integrated automation solution addressing the end-to-end service capabilities for all these domains. Dynamic orchestration from Ericsson is not new, so we have launched it 2 years ago, and it is live in many operator environments. Some are serving enterprise customers, like Verizon Zoom project, which we have done and launched 2006. And many of our deployments are serving mobile customers. We have a number of tier 1 references. Those who have launched high level of automation is Swisscom, Telstra, Telefonica, Docomo, and so on. What we are introducing this year is a number of new capabilities, further enhancing capabilities of the dynamic orchestration. But before I go into that, just a brief introduction on the solution itself. This solution is based on a number of standalone products from Ericsson. The central component is the Ericsson Orchestrator, and then the surrounding components supporting the end-to-end use cases are expert analytics, scenic service assurance, cloud deployment engine, driving onboarding and test automation. We'll talk about that a little bit more later. and adaptive inventory supporting the service orchestration automation end-to-end. And finally, Ericsson Network Manager supporting the Ericsson VNFs and the Ericsson radio. We are creating this solution to be able to introduce end-to-end use cases like network slicing, like service assurance, and these use cases are then realized with the Ericsson portfolio, but the solution is very much open, and many of these components can be fully replaced with third-party equivalents. Going into the exact details of this launch, we'll talk about supporting cloud-native applications, a very important milestone for us, because with 5G, a lot of vendors, including Ericsson, will launch cloud-native VNFs. So our own 5G core is built on the service-based architecture, cloud-native microservices, Kubernetes-based deployment. We are also adding the capability into our service orchestration to support the end-to-end 5G network slicing, connecting radio, transport, and core into a homogeneous end-to-end network slice capability. Last year, we have acquired Xenix, an innovative company addressing closed-loop assurance. We have integrated Xenix into our solution. We're going to talk about how is Xenix helping us to reduce the operational cost. Going through the list, WAN orchestration, we have done a lot of interesting announcements the last year. Our partnership with Juniper. Now we are expanding our capabilities in the transport with an end-to-end, multi-domain, multi-vendor WAN orchestration capability. A few words about that a bit later. And then finally, a very interesting and I believe a unique Ericsson product, Cloud Deployment Engine, which is intended to automate the early part of the project, the onboarding, to support DevOps and the continuous deployment and delivery models, which are very much essential now with the introduction of 5G. We believe the frequency and the level of new VNF and new version of the software will be very often needed. Most deployments have around 30% dedicated to testing and onboarding, and by automating this step, we will be able to reduce the time to market and the operational cost. Going into each capability in more details, we start with the first one, supporting cloud-native applications. The dynamic orchestration is intended to create network services across central edge and on-prem sites. And the network service is connecting VNFs, physical nodes, and now also container-based network components. We are focused on the Kubernetes-based container environment, and we are able to deploy not just individual VNFs, but the entire network service, which means we can deploy the VNFs, connect them to the surrounding environment, connect them to each other, push down the configuration, and make the entire hybrid end-to-end service available. Dynamic orchestration is based on a number of open source components. We are following two communities, Etsy, which is driving very much the LAN architecture, and then ONAP. Ericsson is a platinum member of ONAP, and our strategy is to be able to support both Etsy and ONAP compliant VNFs in the same time. So that means that Ericsson Dynamic Orchestration southbound has ONAP compliant interfaces for like fault, performance, and configuration management. We are also working with a number of projects actively. And as one example, the ONAP service designer is actually part of the Ericsson Dynamic Orchestration commercial solution. So we are taking that ONAP component and built it into our commercial product. Going forward, 5G network slicing is very much the main new capability of the 5G solution. And on this picture, you can see the capability to orchestrate the 5G core, the service-based architecture components. In this picture, you can see 3 network slices. And exactly what we are showing here, we can also demonstrate in proof of concept capabilities. And we are already running a number of trials with some of our customers. One well-known engagement with our customers is with Swisscom. And we have published a number of references showing how we have used network slices to address a transportation use case, and a very interesting use case with an Industry 4.0 company in Switzerland. Basically addressing the business need of that enterprise or that manufacturing site to replace Wi-Fi, to introduce a private radio to be able to cover the entire manufacturing site, and also the warehousing for tracking the goods through the factory, but also having the capability to replace, for example, the factory gigabit Ethernet with a wireless solution. And the business case behind it is the capability to rapidly reconfigure the manufacturing site without taking the long time needed to recable the robotic manufacturing on the floor. So we will see that many of our customers will engage in both technology trials, but also in business model development, because addressing these complex vertical use cases will also open up need for our customers to find partners in the industry and to introduce these innovative capabilities to the large variety of industry verticals. What we provide is an end-to-end service orchestration, 5G network slice capability, which can be both dedicated to that industry vertical or shared between a number of different industry verticals. Going into the actual production, a lot has been said in the industry around closed-loop automation, and what closed-loop actually means is that we can collect KPIs like fault and performance management from OpenStack, from the data center infrastructure, and from the VNFs themselves. And based on that information, we understand the topology of the service, and also understand what corrective actions can be taken in an automated fashion. And that corrective action is then sent to the orchestrator, which then executes those corrective actions. What we have done so far and launched are VNF level healing, scaling, and migration. And I will talk a little bit more about that in the next slide. What I want to mention as well is that we are working on a capability to integrate analytics in a better way, so that we are not just acting on thresholds, but also being able to predict and act before the actual problem occurs. What is very interesting with Xenix is the capability to integrate to a large number of components in this complex environment. So Xenix is able to integrate to the domain manager, to OpenStack, to Kubernetes, to the VNFs themselves, to the data center infrastructure. And through this integration, Xenix is building a service model. Why is this important? Because our customers, through this service model, can actually understand how is their service connected through this complex environment. To make an example, like mobile broadband on a highest level is broken down into a number of VNFs. Like let's say in the 4G environment, that is the packet gateway and MME. That is broken down into a number of VNFs in OpenStack. And those VNFs are connected to the actual OpenStack and to the physical hardware and to the physical switching infrastructure connecting all the components together. And through this tree structure, we can visualize the end-to-end service and also provide KPIs for every layer and every component to understand how is the service behaving and how their individual layers are performing. And once this tree structure and analysis is available, then we can automate actions if we see that something is not working as it should. And those closed loop actions, the way how we have implemented, are broken down layer by layer. And each layer has its own level of autonomicity. So we have seen 3 layers: the closed loop on infrastructure level, on VNF level, and then on the highest level is the closed loop on the service level. All these levels can be connected to analytics so that it's not just threshold based, but also predictive AI based information driven into the decision process. We have launched so far closed loop for infrastructure and closed loop for VNFs. And what we are launching now with this introduction is the closed loop for service. And to make an example, I can talk about case healing and scaling. Like when we see that the VNF is failing, either due to an OpenStack failed or hardware has failed, or the VNF has failed due to problems in the application layer. Based on that information, our orchestrator can already now do like a healing action where we recreate the failed virtual machine, or we see that the actual VNF is overloaded, and we create new VMs and basically scale out the node. If the fault is such that it cannot be repaired due to the problem in OpenStack or hardware, then we migrate the entire VNF into a healthy part of the data center. So these actions can be performed already today using the VNF manager. And now with Xenix, we can also perform complex corrective actions. To make another example, if an EPG is dropping packets and the node is not overloaded and there are no problems with the OpenStack itself, it's not easy to understand why this is happening. So this kind of information is visible in Xenix because due to the tree structure of the service, we can understand that, okay, the service is also dependent on switches, data center gateways, links, etc., which can, of course, also be overloaded. And then based on this service knowledge, we can take corrective action on the service level and fix the problem. And moving forward from the data center environment into transport, what we have already launched in 2018 is our partnership with Juniper. We have introduced the Juniper MX series into the transport solution, and we have also integrated Juniper Northstar into the Ericsson Network Manager, so that we have a single management system which can address the complete needs of the Ericsson transport domain. Going one level up, we are launching now a WAN orchestration layer. It's a multi-domain, multi-vendor WAN orchestration engine, which can talk to a number of different transport domains from different vendors, like Juniper, Cisco, and so on. And through the service orchestration, now we can connect the networking in the data center with the transport domain until the edge of the network in where radio or enterprise components are sitting. So with this, we have basically completed our service orchestration capability so that we can launch end-to-end services spanning across all three domains. And then finally, one of the most unique components of the solution is the cloud deployment engine, addressing the onboarding and continuous deployment needs. With 5G, we see that we're going to have a need to launch new capabilities quite frequently, to make updates quite frequently, and to introduce entire new services into a network quite frequently. The capability what this product provides is a continuous deployment and delivery into an operator environment. So this software component started initially through an engagement with our Verizon customer, and that's where we understood that in an extreme multi-vendor environment, there is a need to automate the testing and the software introduction, because usually this process is eating up roughly 30% of every project time. So by automating it, we shrink the time to market and reduce the cost drastically. Our engine now supports test cases for SD-WAN and also for mobile broadband, IoT, and VoLTE. And we have also added now test cases to be able to support the 5G capabilities. I have to also stress that this is not an Ericsson-only engine. In the Verizon deployment, actually, we don't have any Ericsson VNFs. Most of them are from third-party vendors like Juniper, Cisco, Viptela, and so on. However, we also support the Ericsson mobile core and the Ericsson voice over LTE system. But the test engine is created in such a way that we can support a number of other vendors' VNFs and other vendor services. We have a partnership with Ixia, so that the Ixia engine is integrated into our cloud deployment engine. So finally, to wrap it up, so Dynamic Orchestration has introduced a number of new capabilities The start of the project is the cloud deployment engine to automate the onboarding and the testing. Ericsson Orchestrator is accelerating the introduction of end-to-end network services through RAN transport and core in a distributed cloud environment. We have also added the capability to support a hybrid network, physical, virtual, and now cloud native running in Kubernetes environment. Through Xenix, we can also close the loop in the operational dimension. First, by enabling an end-to-end visualization of the service, and second, being able to understand what is going on in this end-to-end service and launch a number of corrective actions in an automated fashion. So this, of course, has a huge benefit to our customers. Introducing new software 30% faster, reducing drastically the time to market due to the capability that we can orchestrate an end-to-end service running all the domains, and also in the operational dimension drastically reduce the cost of operating a large number of services in an automated fashion. To introduce automation is usually not a single step. We have created this automation ladder based on our experience working with many customers. And we can basically divide this journey into 3 large steps. The first step is to introduce virtualization. Second is not just a technology step, but also an organizational step, to introduce a data center hosting department running the NFVI environment. And then finally, distributed cloud is a step where the data center technology migrates also towards the edge. Edge can be, of course, a public cloud, an edge of the mobile network, or an enterprise. And these steps from 1 to 10 are also serving our customers to improve the TCO and the time to market. And usually it is not easy to jump over steps. So our recommendation is to start with VNF lifecycle management, which automates the basic operations, instantiation, termination, scaling, healing. VNF onboarding and testing, as I mentioned, cuts the time drastically in the early part of the project. When the data center transformation is executed, the base which we introduce then is an orchestrator, which can then handle multiple distributed sites, have a single pane of glass, understanding what's going on in the data center. And it's also a base to build all other automations on top, like introduction of SDN to automate the networking, introduction of the service topology visualization to understand what's going on in the end-to-end environment, and then going in the distributed cloud, introducing not just individual VNFs, but the entire service, being able to deploy all the VNFs, configure all the VNFs, and launch entire services in an automated fashion. To basically wrap it up, Dynamic Orchestration is a very much open solution. All interfaces follow standards, and we create a reference environment, but our customers have a freedom to replace individual components based on their needs. It's a multi-domain solution running through radio, core, and transport. And we have a number of references also in an enterprise deployment. It's very much multi-vendor. Most of our deployments are with a large number of non-Ericsson VNFs. We also keep a list of our experience with other non-Ericsson VNFs. Now the list is around 200 plus, and it's increasing. And this kind of experience gives our customers the peace of mind that we can manage a complex multi-vendor data center environment. We very much move towards model-driven deployment, moving away from paper-based design. The service designer component, which I mentioned earlier from ONAP, is a tool to design end-to-end services. And once those models are designed, the orchestrator is able to deploy them and then use also models to configure. So we use the ONAP compliant Yang models to configure VNFs and basically put the service in operational phase. Finally, standard compliance. As I said, we follow ETSI and MANO. And towards BSS, we also follow TM Forum standard interfaces. There are a number of interesting references, and we are proud to talk about Docomo, who was one of the first customers. Now they have moved roughly 30 million subscribers into data center environment. And this is also a very good example of us being multi-vendor. Here we don't have any Ericsson VNFs. So Nokia, Fujitsu, NSC, and HP VNFs are in this data center. Telefonica is another very good example. It's a 12-country deployment. So Unica has driven the automation to an extreme. We have, in many cases, a multi-vendor environment, both from NFVI perspective, but also from VNFs perspective. So we have met ZT, Huawei VNFs. In some deployments, we also have Ericsson VNFs. And also the hardware is diverse in different countries. Verizon is our best publicized example in an enterprise environment. And it's one of the most advanced operators in terms of automation. So in this automation ladder, they are on the highest level, already introduced end-to-end network slicing, and the capability to introduce network services in an extremely automated fashion. They basically move from 21 days doing this manually to just under an hour. And then Swisscom is a well-known example running network slices, and I already gave those two examples around transportation and manufacturing use cases. In total, the Ericsson Dynamic Orchestration solution is deployed in globally in many tier 1 customers, and we are proud to see that the number of commercial live deployments is increasing, and through automation, through engagement, we see the number of live customers actually accelerating now due to maturity of the technology, due to the help what Ericsson provides to our customers. So wrapping up, dynamic orchestration is a single orchestration solution for radio transported core, managing virtual, physical, and cloud-native functions. AI-powered closed-loop assurance automatically adapts to real-time needs, keeping the SLAs. ECD, automated onboarding, accelerates time to market in a multi-vendor deployment. And then network slicing is enabling our customers the capability to explore new business models and address the promises of 5G.